going to build upon what I spoke about in lesson 4. And so in lesson 4, I did not say greatest common factor or GCF, but I demonstrated that. And so this is really building upon the last video. To identify the greatest common factor, I need to first list the factors. So to list the factors of 6, I'm thinking what numbers going all the way up to 6 evenly divide into the value, in this case 6. 1 divides into 6 because 1 times 6 is 6. 2 divides into 6 because 2 times 3 is 6. And there's no whole numbers between 2 and 3, so I know I've listed all of the factors of 6. 1 times 8 is 8. 2 times 4 is 8. And 3 does not evenly divide into 8, and there's no other numbers between 2 and 4, no other whole numbers. Now I'm going to look at the list. I'm going to select the largest common number in both list of factors. And in this case, that would be 2. There's also a way to do this, so I'm going to show you 2 methods. The second way is using a prime factorization tree. So I'm going to write down 6, and over here I'm going to write down 8. And so I know 2 times 3 is 6, and I know 2 times 4 is 8. Now 8 can also be broken down into 2 times 2. So 6 is composed of the prime numbers 2 times 3. 8 is composed of the prime numbers 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Now I look at both lists and I find all the common values. If there's more than one common value, I will multiply them to identify the GCF. I'm going to start by listing the factors of 18, 24, and 36. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. 4 does not evenly divide into 18. Neither does 5. And there's no other whole numbers between 3 and 6. Same concept. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. The only whole number between 4 and 6 is 5, and it does not evenly divide into 36. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. 5 does not evenly divide into 36. 6 times 6, but we don't have to write 6 twice. We only have to write the value once. 7 does not evenly divide into 36, nor does 8. Now I'm looking at the list, and I'm starting at the very back here. So 18 is not in all of these lists, 9 is not in all of these lists, but 6 is. So the GCF of 18, 24, and 36 is 6. Now, it is important as you grow in your mathematics to learn more than one way to achieve the correct answer. So most students at the elementary level prefer this method, but as you get into upper level math, they're going to want you to understand how to still achieve the correct answer, in this case 6, but using a prime factor tree. So I'm going to start right now. Okay, how do I get 18? You could start with 1 times 18. You could do 2 times 9. It's really up to you. I'm going to start with 2 times 9. Now the only way to achieve 2 is 1 times 2. It's not necessary when I have to only demonstrate 1 times the value itself, but feel free to do that. And how do I achieve 9? 3 times 3. So 18 is achieved by taking 1 times 2 times 3 times 3. Okay, 24. I could start with 1 times 24. I could do 2 times 12. I could do 3 times 8. You choose. So maybe this time I start with 3 times 8. Now the only way to achieve 3, because it's a prime number, is 1 times 3. So if you are not familiar with the term prime number is a value or a number in which the only way to achieve that number is 1 times itself. So for instance, the only way to get 2 is 1 times 2. There's no other way. The only way to get 3 is 1 times 3. 4 is not a prime number because outside of 1 times 4, we could also say 2 times 2. That makes it not prime. Okay, how do I achieve 8? I can take 2 times 4, but 2 is also 1 times 2, so it's prime. And 4 is 2 times 2, and we know that 2's are 1 times itself. So here we go. We have 1. If I took in a calculator and did 1 times 3 times 1 times 2 times 1 times 2 times 1 times 2, I would achieve 24. Now, when we have numbers, so I'm going to organize this. 18 using the prime tree factor would be 1, 2, 3, and 3. And just because you're learning this at this time, I'm going to write them down more than one time. Okay, 24 is achieved by how many ones? 1, 2, 3, 4. 1 times 1 times 1 times 1. Okay, how many 2's? 1, 2, 3. 1. Oops, sorry. How did I get a 4 in there? I meant to be a 1. 2 times 2 times 2. So I've put down the 1s. I've put down the 2's, and now a 3. And I just want to make sure this is right. 1 times 2 is 2. 2 times 3 is 6. 6 times 3 is 18. 1 times 1 times 1 times 1 is 1. Times 2 is 2. Times 2 is 4. Times 2 is 8. Times 2 is 24. Okay, I want you to press pause and try to break down 36 into prime numbers and then write it below. Come back to the video once you've done that. Come back to the video once that's completed. All right, I'm going to start with, I could start with 1 times 36. Again, you could do 2 times 18 or 3 times 12. It's up to you. Maybe this time I start with 2 times 18. Now, the only way to achieve 2 is 1 times 2. So I've already put it into prime form. 18. 18 can be achieved by 2 times 9 or 3 times 6. You choose. Maybe I'll do 3 times 6. Now, the only way to achieve 3 is 1 times 3. It's in prime form. Notice 1 and 2 are prime, 3 and 3 are prime, 1 and 3 is prime. You're going to keep breaking it down until the numbers at the end of each part of the branch of this tree are only prime numbers. 6 is broken down to 2 times 3, and we know that 2 is prime and 3 is prime. So I'm going to come down below and count how many 1s do I have at the bottom of each branch. 1, 2, 3, 4. 1, 2, 3, 4. How many 2s? 1, 2. How many 3s? 1, 2. We're looking at the bottom of each branch. For some students, it helps to circle the bottom of the branches so they're not confused by the numbers up above. And I'm just going to ensure that I did this correctly. 1 times 1 times 1 times 1 is 1. Times 2 is 2. Times 2 is 4. 4 times 3 is going to be 12. And 12 times 3 is going to be 36. Okay, great. So now I'm going to look for those common values in each list. Like, for instance, look at this. They all have a single 3. Now, this does not have additional 3, so I can't circle, but they all have at least 1, 2. When you have more than one common value, then we're going to multiply to find the GCF. So the GCF, 2 times 3, is 6. Now that hopefully you're understanding how GCFs work, we're going to identify what's the GCF of the two values I'm giving you, and then we're going to use that as a tool to reduce the fraction on the right. So I'm going to choose to show 2 more examples in this video. The first will use what most students prefer to use, and that would be this method right here of listing out the factors. So I'm going to do that right now with 16. To save time, I'm going to press pause and write down the factors. I've listed the factors, and now I'm going to find the largest common value. So they do not have an 18 or 36. Oh, here we go. Here's my 8. So the GCF of 16 and 24 is 8. That's the greatest common factor. Now I'm going to divide the numerator, the top number, and the denominator, the bottom number, by the GCF. 16 divided by 8 is going to result in a value of 2, and 24 divided by 8 will result in 3. So 16 over 24 is fully reduced into the fraction 2. I would like you now to try to do the prime factorization tree. So feel free to press pause, and if you're not confident in this, then just follow along with the video. 25. How do I achieve 25? 5 times 5. Now the only way to achieve 5 is 1 times 5. and 1 times 5. So 25 is 1 times 1 times 5 times 5. 45, I'm going to go with, and we could do 3 times 15, or most of you will recognize 5 times 9. The only way to achieve 5 is multiplying 1 times 5. Notice these are going to be prime numbers on the end of each branch if you did this right. And 1 and 5 are prime. Prime, again, the only way to identify numbers prime is that to achieve it can only be 1 times itself. Now 9 is 3 times 3, but 1 times 3 and 1 times 3. Prime, prime, and prime. So 45 is achieved by there are 3 1s, 1, 1, and 1. There are 2 3s, 3 and 3, and 5. And if you're unsure about this, you can always go back and check. 1 times 1 times 5 times 5 is 25. And if I multiply these 6 values, I do achieve 45. Okay, let's go. We both have 5s. And yes, they have a 1, but multiplying by 1 is not going to do anything. So the GCF of 25 and 45 is 1 times 5, which is in fact 5. So I would come up here, and if I was given 25 and 45, and I was asked to list the GCF, it would be 5. And then if I was asked to use that as a tool to write 25 over 45 in reduced form, I'm going to divide the numerator and the denominator by the GCF, and I will always then receive the reduced or simplified form of that fraction. Okay, this time I'd like you to go to lesson in your book. It's going to be on page 6 and 7, and complete the problems and then check to see if you correctly answered them.